All right, guys, are there any questions on any of the assignments thus far? Any questions on anything we've done thus far? All right. If there's no questions over the homework, what we're doing today is going over angle-angle similarity. Angle-angle similarity. If two angles of one triangle are congruent to two angles of another, then the two triangles are similar. And so the overall proof for this is if A is congruent to D and B is congruent to E, those angles are congruent, then the two triangles are similar. Now, really, we can consider this not so much the angle-angle similarity, but the angle-angle-angle similarity. Because what do we know about any three angles in a triangle? It got to be 180 degrees, yes? Well, if we said that this angle is 70 and this one is 80, we know they add together to be 180, yes? So C has to be 30. Okay, well, E is the same as B. Angle D is the same as A. Well, that means F has to be 30. Because if two angles in one triangle are congruent to two angles in another, well, the third angles have to be congruent. So we don't necessarily need three angles, because as long as we have two, we know the third has to be congruent. So as long as I have two angles in two triangles congruent, we can say that they're similar. We can't say that they're congruent, as we saw angle congruency. When we did that last semester, it didn't work, because the three angles can be the same, but the side lengths aren't connected to each other in any way, shape, or form, because it could be bigger or smaller. So what we're going to be looking at first is determining whether the triangles are similar, and if they are, we want to write a similarity statement. So when we look at this here, how many angles do we need to be able to say, or know, to be able to say that they're similar? Two. Well, we already have one. We have that angle D and angle G are both congruent. They're both right angles, so they are congruent. So I just need one more. So we can say that measure of angle D, or not the measure, because we don't need measure, we can just say that angle D is congruent to angle G. That's one of our angles. Well, they tell us that angle C is 26 degrees and H is 64. Well, I need to either figure out angle E or angle K. Which one do we want to find? Angle K. Well, these all add up to be 180, yes? So we can say 90 plus 64, which gives us 154. And we can subtract it from 180. So the measure of angle K is, do we have another set of angles that are congruent? Yes. We now know that angle K is congruent to angle C, yes? Angle. Do we have two angles that are congruent? Yes. So can we say the two triangles are similar? Yes. Any questions on what we've done so far? So this is our reasoning. Now our similarity statement, we need to name the two triangles. So we can pick which one we want to name first. So we'll put a triangle symbol, and then we need to name one of them. Which one do we want to name first? HGK. We'll name it first. HGK is similar to triangle, because the way we name the first one doesn't really matter. We can name it however we want, as long as we're using the triangle symbol and the three vertices, the three angles. So we started at H, yes? Which angle matches up to H? E, yes? So we'll start with E. Well, we went from H to G, so I need to go from E to D and then C. And that's it. So naming these, using or naming the similarity statement is exactly the same as when we did for congruency, except instead of having our congruency symbol, we have our similarity symbol. And that's it. That's all we have to do for this here. Determine whether the triangles are similar. If they are, write a similarity statement explaining your reasoning. So we do have that angle X is congruent to angle R, yes? We do have that X and R are congruent. Now we just need one more angle, yes? Which angle do we want to find? S. Now to find angle S, well, we know that T, S, and R add together to be 180. So we can add 61 and 21 degrees together first. 1 and 1 is 2, 82. Now from here we would subtract 82 from 180 degrees. 7, 8. So the measure of angle S is 98 degrees. So do we have our second set of angles that are congruent? No, because S is 98 and Z is 99. Those aren't the same. Yeah, because if we check the other angle Y, because if we add 21 and 99 degrees, that'd be 0, carry the 1, we would get 120. And if we subtract 120 from 180, we get 60. Well, 60, Y and T are not the same because it's 60 and 61. So do we have two angles that are congruent? Well, no. So can we say that these are similar? No. They're not similar. Because if we have at least two angles are congruent, realistically we have how many angles congruent? 3. And that's it. All we got to say is this is not similar. We don't have enough information. Show that the two triangles are similar and then write our similarity statement. Okay. Right. Because the angles that have the same number of marks inside of them are congruent to each other. So we can say angle G is congruent to what other angle? R. Because they have the same number of marks, yes? So I need another angle F. We could, but how many angles do I need? Do I have 2? So can we say these two triangles are similar? Okay. Name the first triangle for me. Triangle RQS is similar to triangle does it matter? This one here is unique because it really doesn't matter because all three angles in both triangles are the same. They're the exact same. And from our properties we know already, these are actually all 60 degrees because that's the only way all three angles in one triangle can be the same. So no matter how I arrange these, it's still going to give me the same similarity statement because realistically angle G is congruent to R as we said, but it's also congruent to Q and S. It's congruent to all of them. So no matter how we set this similarity statement up, we would get the right answer. Does y'all see that there? And that's only works. This only works if, well, all the angles in this triangle are congruent to all the angles in this. That's the only way this works, where we can really name the similarity statement however the heck we want, because all three angles in one are congruent to all three angles in the other. All right. So CDF, CDF. So we're looking at this triangle here. And DF, CDEF. So these are the two triangles that we're looking at. Well, we do have a straight line, yes? So those add together to be 180, which means this angle is 90, yes? So which angles are congruent? Well, we know C is 32 degrees, yes? So we do have more than one angle at some of these points, yes? So if we have more than one angle at a point, we can't name it by the vertex, we need 3. So F is the same because they both are at 90. We have two angles that are 90 there. But to make that angle, well, DFE would be 1, and it's congruent to angle. Well, we can start out with DF what? C. Because DFC would be the other one. Because again, when we name an angle with 3 letters, we're essentially tracing the angle out. And the letter in the middle will be the vertex. So for this here, the vertex is F. So we do have one angle that is congruent in both. Now we need to find the other. Or find another one. Well, we can figure out what this angle is here. Because these 3 angles add up to be 180. So we can say 90 plus 32. 2 is 122. And we can subtract it from 180, yes. Which would give us 58 degrees. So the angle we just found is angle what? Well, how many angles are at D? Well, we have this one and so FDC, yes. Because D would be in the middle because it's the vertex, but we just need to trace it out. So we can say FDC or we can say CDF. It is congruent to angle E. Now it seems weird that we can just say angle E, but we've had to use 3 letters on the other 3 angles, yes? But looking at angle E where it says 58, how many angles are there? 1. We only have 1. So we can use the vertex. Angle C is the same way. There's only 1 angle there, so we can just use its vertex. So we do have 2 angles, yes? So that means we can say triangle what? Is similar to triangle. So C, so we started out at 32, went to 58, and then down to the right angle. So where's 32? D. They kind of gave us those. But especially writing these out, if it helps to trace them out, go on and trace them out so that you see how they match up. Questions on this here? Any questions on any of this here? We could have also used the angles or picked the vertices of the angles to work with to match those up as well. Show that the 2 triangles are similar. So we want to show, I get a highlighter, that ABE, this triangle here, is similar to ACD, the bigger one. Now looking at these 2 figures here, we see that angle C is congruent to angle ABE. These two angles are congruent in both triangles, yes? Is there any other angles that are congruent in both? There is one that they both share. So we're wanting to say these two angles here, yes? But we don't know much about them. It is true that they are congruent, but the reason they're congruent is because they're similar. There's another angle that we don't even need to know the measure to know that it's the same. Because we're still missing two angles in either triangle. So we can't use the fact that it's 180.
Oh,
Yes. Angle A is shared in both triangles, yes? So that means it's going to be congruent in both triangles. Which gives us our angle. And that there we've shown it. Because as long as we have two angles that are congruent, it shows that these two here are similar. Questions on this here? Use angle to show that these are similar. Well, to do that, we need two sets of congruent angles, because if we have them, then we can say that these are similar. So V and V, so SVR is going to be congruent to angle TDU. And those are vertical angles. Since we have more than one angle there, we need to use the three letters to describe those angles in the middle. And they're congruent because they are vertical angles. Angle T and which one? So we wouldn't use TVS because TVS would be this angle out here. But I would agree with angle T. And it's using these parallel lines. That's the question. Is it S or is it R? Because it is alternate interior angles. They're alternate interior angles. By that same reasoning, we could actually say that angle U and angle S are congruent, because those are also alternate interior angles. Any questions on this here? A flagpole casts a 50-foot-long shadow. At the same time, a woman standing nearby who is 5 foot 4 inches tall casts a shadow that is 40 inches long. How tall is the flagpole to the nearest foot? So it's not drawn to scale, so we can't just try to measure and use the picture itself to get there. But what we do have is two triangles. And they're going to both be right triangles. Yeah, we can look at the last one that has it. Now, they gave it to us in feet and inches. And for us to be able to work this, we need it all in the same units. So it's going to be easier to calculate this in inches than it is to do it in feet, because feet is going to give us some weird decimals, especially for 4 inches tall, because that would be 4 over 12, and 4 over 12 reduces to 1/3, which is 0.3 repeated. So that's not a nice decimal to work with. So if we convert everything over to inches, it will tell us that she is 64 inches tall. Her shadow is 40 inches. The building itself is 600 inches for its shadow, or not the building, but the shadow of the flagpole is 600 inches. So, yes. So the height of the flagpole is x. What do we put underneath it? 60 what? 64 for the height of the woman. What do we put in the numerator of the second fraction? 600 over 40. Because the shadow for her is 40 inches. Yes. So we can do 600 divided by 40 and get 15. What would we do next? Multiply both sides by 64. Well, here 64 and 64 would cancel, leaving x by itself. Yes, because that would be 960 inches. Now to go to feet, well, there's how many inches in a foot? 12. So we would divide this by 12. So the flagpole is 80 feet. And that's it. Any questions on any of this here? And that's it for today.